Hello, today we're going to talk about division properties of exponents. This is lesson 8.5. Here are the pages. We are going to cover all 4 examples with this because it's kind of a review from all the multiplication properties we just covered in the last 3 sections. So they're going to hit all of these in this one section. Alright, so here is our first orange box. So this is examples 1 and 2, so dividing powers with the same base. So this is our like bases subtract exponents. So when we multiplied, we added the exponents. Now that we're dividing, we're going to be subtracting the exponents. So here's a quick numerical example. 3 to the 7th over 3 to the 3rd. Like bases, the base is the 3 here. Subtract these exponents, I get 3 to the 4th, or 81. All right. Tips for using this property, very similar to the ones we have on the board in the classroom right now. Divide or reduce coefficients first. Subtract the exponents with like bases. Write the variables in the numerator until you get comfortable. So when you've done this like bases at exponents, write that answer in the numerator of your fraction until you get comfortable, and then when you're done with that, move the negative exponents last. So very, very similar to what we've been working on. Alright, here is example 1. I have x to the 4th over x to the 9th. These are like bases, so I can subtract these 2 exponents. And 4 minus 9 is negative 5. And remember, we can't have negative exponents, so I need to put the x to the 5th in the denominator to get rid of that negative. And so I get that. All right, that's the most basic example or representation of our rule. Here's a slightly more difficult one. Like bases subtract exponents for the p, so p to the 3rd divided by p to the negative 3rd. 3 minus negative 3 is 3 plus 3, which is p to the 6th. And then negative 4 minus 6 is j to the negative 10th. So I get that. 3 minus negative 3 is 6. Negative 4 minus 6 is negative 10. Now we have to move the j down to the denominator to make that negative 10 positive 10, and I get that. So there is example 1 type problems. Example 2 is a scientific notation problem. So a small dog's heart beats about 64 million beats in a year. If there are 530,000 minutes in a year, what is the average heart rate in beats per minute? So we're going to go through and write these in scientific notation. Okay, 64 million is 6.4 times 10 to the 7th. 530,000 is 5.3 times 10 to the 5th. So what we're going to do here is divide 6.4 and 5.3. That's going to give me the 1.2. And 10 to the 7th divided by 10 to the 5th. This is our like basis. Subtract exponent should give me 10 squared. And I get that. This isn't scientific notation, so I'm done. Alright, if this was 12 times 10 to the 2nd, we'd have to move the decimal back and add 1 to my exponent on the 10. Alright, which is, oh, yeah, we got to convert 120 beats per minute. Alright, let's take a look at this quotient to a power. In fact, let me go back. You're going to try these, and then hit pause, and then move on to example 3. So here's quotient to a power. This is just like our power to a power rule. We had to multiply the exponents. Instead of power to a power, now or a product to a power, now we're quotient, so we're dividing. So here's the straightforward example. The 3 goes both to the 4 and the 5. 4 cubed is 64. 5 cubed is 125. Hit everything inside the parentheses with the exponent. Just like we've said, this is kind of like the distributive property. Okay, you're kind of distributing this 3 to anything inside of the parentheses. Alright, so let's take a look at example 3. Here's 3 over y cubed to the 4th power. This 4, I'm going to hit every one of these with the 4 exponent. So I get 3 to the 4th, and then y cubed to the 4th power. 4 times 3 is 12, so we're still multiplying these powers, just like the power to power rule. 3 to the 4th is 81. Y to the 12th can't simplify, so we are done with that problem. Let's take a look at a slightly more difficult one in example 4. This has negative exponents. Not much different here. The tip when these quotient problems, so division problems, just to get rid of the negative, this is where we can use the word flip. We're going to flip this fraction. Okay, so when there's a negative exponent on the outside of the parentheses, flip the fraction to change the sign. So making 2/3 3/2 removes the negative. Now I'm going to use my quotient to power rule, and I'm going to cube the 3 and cube the 2, and that gives me 27/8. 3 cubed is 27, 2 cubed is 8. And here's our second problem. Remember, we want to get rid of this negative in the exponent, so I'm going to flip this fraction. Remember, this has nothing to do with the sign of this answer. All right. So when I flip this, it's still negative for now. All right. But when I square, so an even power, when I square a negative number, the result should be positive. So our answer we should know is positive. All right. So I'm going to distribute the 2. The exponent of 2 to everything. So the c, the negative, which makes it positive, the 4, and the b. All right. So that gives me that c squared, and then 4 squared is 16, b squared is b squared. Nothing else to simplify. The negative did drop out because we had an even power. I'd like you to try these 4. And so you can pause it, finish that, and so this is a whack. So you got the example from the other quick check and this example. So give these a try, and I'll see you guys tomorrow.